welcome to an ELA Training Services video. This workshop will be on probability. By the end of the workshop, you'll be able to understand the likelihood of events happening using a probability scale. You'll be able to calculate simple probability as a fraction, decimal or percentage, including taking data from a table, and you'll be able to identify and correct common misconceptions. If you haven't already covered fractions, decimals, percentages, and converting between the three, it's a good idea to cover that first and then come back to this session. So, what is probability? Probability is the likelihood that an event will happen. So today, in October, we're going to look out the window and see what's the probability of it snowing today. So outside my window, the sky is blue, the clouds are white. There's not a lot of them. It hasn't rained today. It's cool, but it's not cold enough for snow. So the probability of it snowing today, I would probably say it's unlikely to happen. It's not a high chance. On the other hand, the probability of going to sleep this evening is quite high. It's very unlikely that unless you have insomnia or are nocturnal and a vampire, it's very unlikely that you're not going to sleep this evening. So it's more than a 50% chance. It's probably more than a 75% chance. I'd like to think it's an 100% certainty that you are going to sleep this evening. When we talk about probability, we talk about something called a probability scale. The purpose of the probability scale is that it's laid out between the number 0 and the number 1, 0 being that there is no chance, an impossibility of something happening, and 1 is that there is an 100% chance, completely certain that it is going to happen. For example, an 100% certainty is that it will be my birthday next January. My birthday is in January, it will always be my birthday in January. An unlikely or impossibility would be that my birthday would randomly switch to July. Not going to happen, not when I was born. In the same way that today, in October, it's unlikely for it to snow, it's not an impossibility, but it is quite close to the 0 on the probability scale. As you may have noticed, the words I use to describe probability are interchangeable. So 1 on the probability scale is 100% chance, and it goes down in percentage increments to 75%, 50%, 25%, and 0% or no chance. Another way of saying it is that an event is impossible, unlikely, even chance, likely, or certain, moving back up the scale towards the 1. So as a recap, probability is a number that shows the likelihood of an event occurring. It can be expressed as decimals or fractions between 0 and 1, or as percentages between 0% and 100%. If the probability is 0% or 0 over 1 as a fraction, it's impossible. The event is not going to happen. However, if the probability is 1, it means that the event is certain to happen. It will definitely 100% occur. Let's have a little break and look at this grid. So the first thing that we notice is that it's 10 squares by 10 squares. If it's 10 squares by 10 squares, we know that that is 100 10 squares by 10 squares. We know that that's 100 squares. Of those 100 squares, you can notice that some are different colours. So for example, there is one that is yellow, there is 1, 2, 3, 4, 5 that are pink, there are 10 that are black, 4 that are orange, 1, 2, 3, 4, 5, 1, 2, 3, 4, 4 times 4 is 16, 16 greens, and 5 by 5 blues. 5 times 5 is 25. So these are a few things that we can notice about the grid. I'm now going to show you some statements, and I want you to consider whether they're correct or not. 1/4 of the grid is blue. This is greater than 1/2 because the bottom number is bigger. 4 orange squares is the equivalent of 1 over 4. There are twice as many black squares than pink, so this is a 50% increase. 1 shaded square is yellow, which is the equivalent of 0.1 or 1%. Are these statements correct? If not, can you explain why? Okay, so let's start with blue. 1 over 4 of the grid is blue. This is greater than 1 over 2 because the bottom number is bigger. Well, let's first decide if this first statement is correct. As we said, it's 10 squares by 10 squares, which makes it 100 squares. We also notice that there's 25 blue squares. So, if we want to work out 1/4, or 1 over 4 of the grid, we first need to work out what 100 is divided by 4. So 100 divided by 4 is 25. We know that there are 25 squares here, so 1 over 24 is the same as 25 squares out of 100 squares. So that first statement is correct. 1 over 4 is greater than 1 over 2 because the bottom number is bigger. Well, let's do the same process, shall we? 100 squares, we want to divide it into 2 even sections. 100 divided by 2 is 50. 50 is the same as 1/2, 50 over 100 squares. But we already know that the blue squares here are 25. 25 we know is a smaller number than 50. So, whilst, yes, 1/4 of the grid is blue, it is not greater than 1/2. Let's look at the orange squares. 4 orange squares is the equivalent of 1 over 4. Well, let's expand it out. We have 4 orange squares over 100 squares in total. Let's add them together. Let's simplify it down. So, 4 and 100, what number goes in to both of them? 4. So let's divide 4 by 4. 4 into 4 goes 1 time. How many times does 4 go into 100? Well, we've worked that out over here, haven't we? So that means that it is 1 over 25. Can we simplify that down anymore? No. So 4 orange squares is the equivalent of 1 over 4. No, I'm afraid not. It's the equivalent of 1 over 25. Let's focus on this pink and black squares now. There are twice as many black squares as there are pink. Okay, 1, 2, 3, 4, 5 pink squares, and 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 black squares. Yes, 5 times 2 is 10, so there are twice as many black squares as there are pink. This is a 50% increase. 50% of 5 is half of these pink squares. 5 cut in half is 2.5. So if we have 5 plus an additional 2.5, that's not 10. But if we had 5 and an additional 5, so the same amount again, that's a 100% increase. So whilst again the statement is half correct, it is twice as many black squares as it is pinks. It's not a 50% increase, it's a 100% increase. Right, lastly, 1 shaded square is yellow. This is the equivalent of 0.1, which is 1%. Let's expand it out again. It's 1 square out of 100 squares. Can we simplify that down? No, we can't divide anything into 1 to make it smaller. So 1 over 100 is not 1%. It's 1 over 100. Let's look at it as a decimal. So if it's 1 over 100, it's 0.001. Because remember, hundreds, tens, units. It's 1 in 100 units. So again, not a correct statement. We're now going to consider that this game has been turned into this grid has been turned into a game. The game is that a light will flash under each square in turn and randomly will stop on a square. We need to work out the probability of it stopping on a blue square. So it's the same grid. We know that there's 25 squares here because we did 5, 1, 2, 3, 4, 5 times 1, 2, 3, 4, 5. 5 times 5 is 25. We also know that there's 100 squares in the entire block. So that means 25 of them are blue out of 100 squares in total. So the probability of it landing on a blue square is 25 into 100 over 100. Can we simplify that down? Yes, we can. What number goes into 25 and 100? 5. 5 5s are 25, so 5 over. And how many times does 5 go into 100? That's right, 20. So it's 5 over 20. Can we simplify that down further? We can. 5 and 5, we can divide it by again. 5 into 5 is 1. 5 into 20 is 4. So it's a 1/4 chance that it's going to happen. Can we turn that into a percentage? 1/4 we know is 25%. This is 25% chance that it's going to happen. Turn that into a fraction. So as a decimal, remember, it's 0.25. So we can say that the probability of it landing on a blue square is 1/4 chance, a 25% chance, or a 0.25 chance. The different grid. I'd like you to consider 3 probability questions. I'm going to hold these in our head, write them down, and we're going to hold these for later. Remember, you can ask any question. It would be nice to have some variety of difficulty. It could be, what's the probability that the light will end on a square? Or it could be complicated. What's the probability that it will land on an orange or a red square? It's up to you. So remember, the probability of an event happening is working out the number of ways that an event can happen and dividing it, or holding it over, the total number of equally likely outcomes. And if all the possible events happened, the probability is 1. So let's look at this as an example. Emma. Emma supports the Blackburn Rovers, and on Saturday they're playing against Manchester United. Emma says that they can either win, lose, or draw, and therefore have a 1 in 3 chance of winning. Is she correct? Well, let's look at this again. If probability is a fraction of the likelihood of something happening over all of the outcomes, what are all of the outcomes? They could either win, lose, or draw. That's 3 possible outcomes. 3 possible outcomes. The outcome that Emma really wants is that they win. That's one option. So it's a 1 over 3 chance, a 1 in 3 chance that she'll win. So she is correct. Well done, Emma. If we were to put this on the scale, we first need to change it into a decimal. So we know that 1 over 3 is a third, and that a third is roughly 33%, or 0.33. When you're drawing on a probability scale, you just draw an arrow to the point where you believe the likelihood falls. Now, 0.33, I'm going to say, is roughly there, so that's the probability that the Blackburn Rovers will win the football match. Earlier, we asked the probability of it snowing today. Now I said it was down here at no chance, impossible, not likely to happen. Whereas the possibility of going to sleep this evening, the probability of going to sleep this evening for me is 100%, basically, which is almost a certainty. So these arrows indicate where you believe the probability of an event will fall. Have a think and talk amongst the people with you about the questions that you've asked yourself on the grid. Where do they fall on this line? Okay, let's put this into a different example. So in a game, there are 3 events for an ordinary fair dice. Dice, as we know, is a 6-sided shape with the numbers 1 through to 6 on it. 1, 2, 3, 4, 5, 6. 3 of those numbers are odd, 1, 3, 5, and 3 of those numbers are even, 2, 4, 6. So the rules are, if it's an odd number, Aisha will win a prize. If the number is greater than 6, Sam will win a prize, and if the number is even but less than 3, Suna will win a prize. So let's look at Aisha first. She wants an odd number, so as we've said, there are 6 numbers on the dice that could possibly be rolled. And how many odd numbers are there? 1, 3, 5. That's 3. That's a 3 over 6 chance. Can we simplify that down? Turn that into 1 over 2, or a half chance, a 50% chance. Let's look at Sam. So again, there are 6 possibilities on that dice, and Sam wants to know if there's a number greater than 6, because that means she will win a prize. Now the problem is, on a dice, the numbers only go up to 6, so there are no numbers greater than 6, which means there is no chance, a 0 over 6 chance, that it will land on a number greater than 6. This means that the likelihood, the probability, of Sam winning is impossible. It will not happen. I'm going to look at Suna. So again, it's an out of 6 chance because it's the same dice, 1, 2, 3, 4, 5, 6. But this time Sunil needs it to land on a number that's even, but less than 3. So that means it has to land on the number 2. So the 2 is only on a dice 1 time. So that means it's a 1 over 6 chance. Who is most likely to win? Well, it's definitely not going to be Sam. Sorry, Sam. Let's have a look. Is 1 over 6 bigger or smaller than 1 over 2? If we think about it in the same fraction size, is 1 over 6 bigger or smaller than 3 over 6? Smaller. Sorry, Sunil. Not likely you're going to win a prize. Aisha has the biggest chance of winning because out of 6 throws, it's likely that it will land on an odd number 3 times. Now Sam has just said that the probabilities should add up to 1, so it's certain that one of us will win. Is she right? Well, the problem is it doesn't add up to 1. 3 out of 6 plus 1 out of 6 is 4 out of 6, because we know that there is a 0 out of 6 chance that Sam will win. So 4 out of 6, is that the same as 1 whole? No, I'm afraid it's not. So Sam's incorrect. There's only a 4 out of 6 chance that somebody is going to win. Or if you simplify that down, it's a 2/3 chance, or a 0.75 chance, or a 75% chance that somebody will win. So remember, the probability of all possible events is always 1. If Sam had a different number she was aiming for, that had a probability of 2 out of 6, then she would have been correct. They would have all have added up to 1, and it would have been a 1 certainty that somebody would win. Sometimes you have to pull information out of a table. So the first thing we have to do is look at the table and understand what the data is and what it's showing us. So the first column is the number of text messages sent, anywhere between 0 and more than 21 in one day. And the second column is the number of people who have sent that many texts. So 3 people have sent 0 texts, and so on and so forth as you move down the rows. The last row shows that there is a total of 30 people in this. So we don't need to spend time working out what 3 plus 3 plus 7 plus 10 plus 5 plus 2 is. We already know that there's a total of 30. We're then going to look at the question. If somebody is selected at random, you assume that that's a true random and that everybody has the same chance of being selected. We're then going to look at the probability that a person selected has sent fewer than 11 text messages. The first things we have to do is work out how many people sent less than 11. These are all these people up here. 10 is less than 11 to 6, 5 to 1 and none. That counts. Still none still count. So 7 plus 3 is 13. So we know that 13 people out of a total of 30 people have sent less than 11 text messages. By 13 over 30? No, not in this case. So 13 over 30 people is your probability, 13 over 30. The next part asks us what the probability is of someone sending more than 15 messages. This time we're looking at these people here. So remember, 5 people have sent 16 to 20 and 21 messages have been sent by 2 people. So 5 plus 2 is 7. This time we need to put it over the total. 7 over 30 is our fraction probability. Can we simplify 7 over 30? No. And for comparison's sake, we probably wouldn't anyway. So we're looking at the probability that more than 15 messages were sent that day by the person we selected at random. 7 over 30. It's less than people that have sent less than 11 texts, but it's still a significant number. It's not half, but it's not 0. Okay, some practice questions now. Let's talk about Pierre. So Pierre's a teacher and he has 13 boys and 17 girls in his class. We first need to work out how many children he has in his entire class. So we're going to do 13 plus 17 and see how many children we have in total. 7 plus 3 is 0. Remember to carry the 1 to make it 10 and add up the tens column. 1, 2, 3. So Pierre has got 30 children in his class. We then want to know what the probability is that one of the students he selects at random is a boy. So remember, 13 boys over 30 students in total. Can we simplify that down? No. So your answer would be 13 over 30. Beautiful. Okay, another question about Pierre. So he's now going to work on the train, and he records whether his train is late or on time, and after 20 journeys he finds this data. 15 times his train is on time, and 5 times it's late. So we're going to mark with a cross, or an arrow, on the scale where the probability is that the train will be on time. So again, we know that it's out of 20 journeys. The 20 is our bottom number of the fraction, or the denominator. And the numerator is the amount of times it was on time. That's 15. 15 over 20. Can we simplify that down? We can. We can simplify it to 3 over 4, or change it into a percentage, 75%. Now the problem is that this is not in percentages. This is in fractions. Decimals, between 0 and 1. So 75% as a decimal is 0.75. So if we look at this, 0, the next line is 0.25, the next line is 0.5, the third line is 0.75, and the fourth line is 1. So if we put a cross on the line at 0.75, that's the probability that Pierre's train will be on time. This just shows us the workings out of how we've got to those answers. Now time to have a go on your own. A group of dancers have raised some money for charity. Here's the information about how much was raised, and remember, it's already worked out the total for you. So you don't need to spend time working out how many people there are in these columns. There are 60 dancers in total. We now want to know the probability that a dancer picked at random had less than £10. So we're looking at these figures here. So, work out for me. What's the probability in fraction or percentage or decimal form that the dancer raised less than £10? You can pause the video here. Lovely. So as we know, the number of dancers is 60. The numbers of dancers that raised less than £10 was 15 plus 23, which makes 38. So that's a fraction of 38 over 60, and it can be simplified down to 19 over 30. Can it be simplified any further? No. So your probability that a random dancer has raised less than £10 is 19 over 30. Well done if you got that. Another one. Here's a fair 8-sided spinner. Laura spins the spinner once. We need to know the probability that the spinner will land on a section that includes the letter E. So let's look at the spinner. No E there. There's an E. There's an E. There's an E. None, 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 none. Hopefully you will have noticed that these are the compass direction points. So we know that there are 8 sides, and we know that 3 of them have got E's in. So first write it down as a fraction for me. If possible, simplify. Write it as a percentage and write it as a decimal. You can pause the video here. Well done. If you got 3 over 8, that's fantastic. Okay, these are from an exam question. Tom's rolled a dice, a fair ordinary dice. It's got 6 numbers, remember? 1, 2, 3, 4, 5 and 6. And we want to mark on a cross the probability that he will roll an even number. You put your cross. Yes, I agree. Yeah, 50% chance. There's 3 odds, 3 evens. 3 out of 6 is the same as a half, which is the same as 50%. Or 0.5. Tom's now going to roll the dice with 12 faces. There's 1 number on each face, but this time the numbers go through 1 to 12. He's rolled the dice and looked at the number on the top face. What's the probability that this number is more than 5? So again, we need to work out how many numbers between 1 and 12 are more than 5. So you have 6, 7, 8, 9, 10, 11, 12. That's 7 numbers. So it's 7 over 12 is your fraction. Which is your final probability. Well done if you got those answers. There are worksheets available if you feel that this has been helpful and helped you crack a bit of probability, then that's brilliant. If not, feel free to watch the video again or contact your tutor for more support. Thanks for watching. Welcome to an ELA